Welcome to Spectrum Policy 101, brought to you by Policy Tracker, which produces a newsletter, research and training courses about spectrum management. Hello, I'm Tim Jenkins with episode 4, looking at the effect of 5G and 6G on spectrum management. In the last while, I bought a new mobile phone featuring 5G 5th generation connectivity. I needed a new phone anyway, but I was excited about how quick it was going to be downloading data on the road. We were also told that 5G would allow all the devices in our homes to talk to the internet and let factory owners, hospitals, or even farmers use their own small radio networks to run their equipment. But is this happening? Is 5G a revolution? And how keen are mobile telephone companies on sharing spectrum with those newer users? Or, in the end, is 5G just another step in the evolution of mobile networks? Well, there's a debate about that, and Professor William Webb and Ulrich Rehfuess are on either side of it. William used to work for the British regulator Ofcom. He's now with the Access Partnership Consultancy, and Ulrich is head of spectrum policy at Nokia, which makes mobile communication network equipment. Welcome, both of you.
Hi, Tim.
Hey.
Well, listen, there's one thing I want to clear up straight away. I thought that 5G was just the use of higher frequencies in the spectrum. And the higher the frequency, the more data you can transmit per second. But that's not what 5G is it, William?
Not strictly, no. So 5G is actually a standard. And a standard is what you need for different devices to be able to talk to each other. It's like a form of handshaking. It means that one device knows the language the other one is talking to. And that standard could actually be deployed in any frequency band. It's not restricted to a certain band. It just so happens that the band that 5G is predominantly targeted in is a higher frequency band for just the reasons that you rightly said, Tim, that it's got more spectrum in those higher bands, and that therefore allows higher data rates to be delivered. And so there is, to some degree, a bit of a link between 5G and higher frequencies, but that's a temporary factor, and 5G will gradually expand over many other frequency bands over time.
Okay, but as you're kind of hinting there, Ulrich, the allocation of spectrum to 5G, that's an important part of the discussion, though, isn't it?
Yeah, definitely. And, well, maybe building on William's statements, there is a need for low bands if you want to do wide area coverage. And the European Union, at the times, I think the UK still had been part of the European Union, agreed to have the 700 megahertz band released from television and made available for that purpose, so to really have wide area 5G coverage. But certainly performance is somewhat limited in terms of bandwidth, as there is not so much RF bandwidth available in such a low band. Then there is this 3.5 gigahertz range as a pioneer band for 5G, offering much higher RF bandwidths, translating into higher data rates. And then there's certainly the millimetric wave range, which is entirely new to 5G, which have not been there in previous generations.
William, how easily did the discussions about, which spectrum we use and what the uses will be, how difficult was that discussion to get to the protocol that we call 5G now?
So the spectrum discussions are always very difficult. And the reason for that is because all of the radio spectrum that is useful is already being used by somebody. It may not be cellular, it may be satellite systems or what's sometimes called fixed links, point-to-point communication channels. It may be used for research purposes, for broadcasting. There's for radar, for military applications. There's no end of other people that want to use the spectrum. And so for cellular, for 5G, to get more spectrum, it needs to find a band that where others can be vacated from that band. They can be moved out and that band can be made available. And that's always a very difficult process. People generally don't want to move out. And of course, there's over 200 countries in the world, and ideally we'd have the same frequencies in every country in the world, but each country is in a different starting point. So this whole discussion and debate about which spectrum to use typically takes 5 years or more to unfold, with a lot of negotiation and discussion around the world.
And then in companies like yours, Ulrich, you're waiting for these protocols to be released so that you know what technology to make, what to manufacture.
Yeah, actually, we are pretty much shaping those protocols in standardization like 3GPP, but that's only the technology side of the game. And what spectrum-wise we need really are these international discussions on a regional level. So for Europe, it's CPT with 46 member states trying to find bands that can be harmonized for future mobile use, but certainly looking at all other services at the same time. And then there is the ITU on a global level, and that's this quite lengthy process, agreeing regionally on something, then trying to promote that on the global level, coming back with the results from the global level, and then maybe eventually defining the exact technical details when finally then specifications can be built for those radio frequency components again by 3GPP. But it's a pretty interlinked process, and as William said, on the spectrum side, it's very lengthy with a diverse legacy, diverse interest of countries. And while we as industry can only consult basically in that process, it's governments basically who decides in the end what to do with the spectrum.
Okay, well, let's go back to that question I was posing there at the start, which is, how great 5G was. Was it, William, revolutionary as we were promised?
So I would say no. I actually wrote a book way back in 2016 called The 5G Myth that set out why I thought it was actually an evolution rather than a revolution. That actually it's an improvement on 4G, no doubt, and it's not a bad thing, but it just makes 4G a bit better. And for many people, that improvement is not really noticeable. It's a bit like you being told that the next car you're going to buy can go 200 miles an hour. Well, fine, but the speed limit is only 70, so there's no benefit in you in that. And similarly, for most people, for what they do, the higher speeds of 5G are of no benefit. You can stream video perfectly well at about a megabit a second, so having 100 megabits a second is no advantage in that respect. So I'm absolutely not saying it's a bad thing, but I think it is a relatively small incremental step forwards rather than the revolution that many talked about and still talk about when they mention 5G.
Okay, well, Ulrich, I'm afraid I have a bit of a confession here, which is I've not been terribly impressed by 5G because I'm looking at it from a layman's perspective, which is I want my internet to load very quickly, and I'm not really seeing that. Do you think in the end 5G didn't deliver what we were hoping it was?
No, I don't think so. So I have seen very decent performance of 5G networks, well above what had been possible on 4G with personal devices. But I think that's not the main point. And whether it's a revolution where a king is kicked out of office and something else comes, we can certainly debate. I think 5G opens wide new spaces, so it complements the existing 4G networks with new things. And you mentioned a few of them, like 5G use in a factory, 5G use maybe in agriculture, 5G use for connected vehicles, communicating for better safety and better traffic flow, and so on and so forth. On the technology side, there is a really new aspect with the millimeter wave technology, allowing for many more antennas at both sides of the radio link, only possible because the wavelengths of those very high bands get very small. So you can integrate many antenna elements, maybe 256, just to state one number, into a device. So I struggle a bit with saying one thing is evolutionary, another thing is revolutionary. I think there are really new elements to 5G, some of them still to really develop completely and hit the marketplace. But what we see as evolution is also quite impressive on the mobile networks now, with the deployments in 3.5 gigs, for instance, delivering really many hundreds of megabits per second quite consistently. Another debate certainly is how much does an individual user need that. On the other hand, he's really quickly off the channel, downloading a certain file or whatever. So it's great user experience for him. And then there's certainly capacity created on those networks so that many users in a certain area can experience very good quality and way beyond what they could experience capacity-wise on a 4G network, for instance.
Okay, Ulrich. Ulrich Rehfuess there and William Webb. Thanks both of you for digging into the detail there for us. Bless you.
Pleasure.
So what comes after 5G? Well, of course, 6G. But it's not due to roll out until around 2030, but planning and negotiation, as we've hinted already, has to take place now. So what could 6G look like? And what spectrum will it use? Marja Matinmikko-Blue will look into the crystal ball for us. She's Director of Sustainability and Regulation at the Oulu 6G flagship university in Finland. Hello, Marja.
Hello.
Thanks for joining us. I get the impression that 6G is partly driven by guesses again about what people want from mobile data in the future, like virtual reality. Is that right? What is 6G meant to deliver, please?
That is a great question, and we don't really know the answer, but I will give my views on what it could be. And I've already been doing this for some years because Finland started 6G research in May 2018, so it's almost 5 years ago. And we were the first to deliver this joint consensus on the vision of 6G in these world's first 6G white papers already a few years ago. And there the idea was that 6G will combine the communication service with other services like locationing, positioning, computing, sensing. All these things will come together. That's a technical dimension. But the idea of 6G is to bring together the physical world, the digital world, and the humans. So there's a lot of talk about machines. Machines are users. They are becoming the users already now. But still humans will be the key driver for the 6G development. And one thing I want to highlight every time I speak about 6G is sustainability. So that is the new big driver that is driving 6G R&D right from the very beginning.
We'll talk about sustainability again, Marja, because that is a big issue, and it's going to be written into these negotiations that we're already seeing taking place to define what 6G is. The use of power for all of these networks that we're going to depend upon. We'll talk about that in a sec a bit more. But, tell me, all of these aspects will require a great deal of data very fast. So what bits of the spectrum are we looking to deliver that?
So usually for each new cellular generation, there has been new spectrum. For 5G, we went to the mid-bands, 3.5, for example, and then the millimeter waves. So there are new bands usually. The same discussions will take place for 6G, like what would be these new bands. And obviously going higher in the frequency rates is one dimension to get wider bandwidths, more capacity. But just like Ulrich said, they will be deployed also in the existing bands. So those bands that are for mobile communications today, the technology can be upgraded in those bands to the newest technology. 5G will come to some of the bands that are now used for example, 3G. So that happens. 6G could be used for the bands that are used now by the prior generation. So existing and new. And there's the new interesting part that William was saying, that spectrum is already allocated. There are already named users. Whether they use it or not, that's yet another question. And whether they use it in every location or not, that's a good question. So in 6G, it's natural to ask, how do we gain access to this spectrum? And there I hope that we will finally see more shared access to the spectrum while protecting the existing users' rights, but still admitting new entry, especially in local areas.
How keen are existing users to share? Because at the moment they're sitting pretty if they're incumbents. How fraught is that a discussion?
They are not eager to share. If you have something, you don't want to give away the rights. So those are the hard discussions that people were referring to earlier.
And regulators have to take the bull by the horns, that they have to find a way of making sure it's not just companies with deep pockets, with lots of money, that dictate these discussions we're having now and get the best spectrum.
Exactly. So stakeholder management is what the regulators are really doing. They get claims from different stakeholders. They get conflicting claims, and their task is then to reach consensus And these are long-term consensus, like it's strategic management of this scarce radio resource, this spectrum resource. And it's not just a national, like one country issue, but there's so much international and regional harmonization because the radio waves, they don't stop at the border of the country. So it's really complicated. And then the stakeholder claims are different, and different stakeholders dominate in different countries. So it's really a complex topic. That's why it's so fascinating research topic.
It varies around the world. There are different cultural factors and technical factors.
Yes.
Okay, that's interesting. Now, another thing that's got to come together, that will come together through work, through effort, and also just because it does, the technology that will allow us to use higher and higher frequencies. I think that's called, for example, terahertz spectrum. I think you mentioned millimeter and sub-millimeter band. That's another way of saying high frequency. And I'm wondering whether, because high frequency means less range, whether actually even mobile phone companies will be able to be persuaded that they can share spectrum.
So the use of these very high frequency bands like the terahertz, the use of them is different from the lower bands where you get good coverage. So you can get range in the high bands if you have extremely directional transmissions. So you can get some range, but in general, the range is limited to local areas. So for the communications, that presents challenges if you want to communicate further away. But for sharing and interference management, it's easier because then also your interference is local. But of course, the goal in wireless is to get capacity, is to get the transmissions, good quality transmission. So that's it's a trade-off.
So your factory won't interfere with my factory if we use high frequency little local radio networks. Yeah. As long as you don't find a mobile phone company wanting to use small hotspots for your telephone on every lamppost down a street, which is feasible.
Yeah.
Okay, that makes sense. Right. Well, we talked about sustainability. You were, frankly, very eager to speak about that. What are you talking about? How much energy is mobile telecommunications taking up these days?
Energy is one element, and it's obviously a critical element because the operators pay their energy bills every month. So it's a clear cost thing, and then reducing cost is a clear motivator to reduce energy consumption. But energy is just one aspect. So sustainability is a way bigger thing. Sustainability has three perspectives: economic sustainability, environmental sustainability, and social sustainability. And then under this environmental sustainability, energy consumption is one. And there are efforts to attempt to reduce the energy consumption, improve energy efficiency. Usually the energy efficiency is better the newer the technology, but then the total energy consumption is still increasing. So that energy has been a design criteria for quite some time, but it will even be more and more in the future. But that's not the only thing. Also, the use of materials, like the mobile phones themselves, their environmental impact is not just the energy consumption, but also much more than that. So it's a complex topic. And I want to bring it up in every occasion.
Yeah, and you were talking there in the end about these rare earth metals that we dig out of the soil of the earth to put into the components in our mobile phones. You talked about social sustainability as well. What's that?
Social sustainability, it's like we are the people in this planet, and we are so responsible for this planet, and also the people here. And communications, ICT systems, the services and the infrastructure, they play a critical role in helping people advance their conditions. For example, gaining access to the internet can provide benefits to people. Like there are a lot of studies about that. And if you're out of that, then you are not in the same position as the rest of the world. But it's a very big topic, like how we could enhance the use of ICT services and technologies to really improve social sustainability. The UN SDG framework is the concrete framework that nations are committed to achieving. And there are 169 targets only there. And achievement of many of the targets depends on the availability of the ICTs. And ICTs can help to the achievement of many of the targets there.
I absolutely get your point about the stakeholders like you and I and the social sustainability argument. I remember talking to a farmer. He grew onions in West Nigeria, and simply because he had a 2G mobile phone for the first time, he was able to ring up 2, 3, 4 different villages to find out where he'd get the best price for selling his onions. And his profits doubled. He was able to sustain his family much more at a higher level, simply through making these telephone calls on a mobile phone. Couldn't do it before the mobile phone network was there. Right. Well, that's all very interesting. How difficult is the process going to be now for deciding what the protocols should be? Will those kind of sustainability rules be encoded in those regulations to form the 6G protocol?
So if you look at the role of 6G, I see a twofold role. It is this enabling effect that the mobile communications have to help different sectors of society to help achieve sustainability targets. So that's the enablement effect. And then there are metrics to quantify how that is. For example, how to reduce greenhouse gas emissions in different sectors through the use of ICTs. That's the enablement part. Then the other part is the 6G systems themselves, and then what the sustainability requirements for them should be. Environmental, social, economic. For the environmental sustainability requirements, the discussions have just started. Like it's not clear how to incorporate the energy efficiency, energy consumption. That is a clear thing. That in 5G, energy efficiency is a performance indicator, but there is no target value for that. So that is something that those discussions have taken place before, but there was no consensus. Now in 6G, we are again in the position that, well, at least that one is clear. We have to talk about that. But what the other metrics are, key performance indicators is one thing, but many things are also like value related, especially the social sustainability related things, value indicators, key value indicators. Now the discussion is open, like what those could be.
Marja, thank you for that.
Pleasure.
That's great. Well, Marja Matinmikko-Blue there. It's become clear to me then that 6G, like the 5G protocols before them, are as much about politics as it is spectrum, and it's as much about cash as it is technology. And it takes a long time to settle all those factors down. That look into the future ends our series of 4 podcasts, Spectrum Policy 101. In case you missed any, you can always go back and see why regulation was needed in the first place and how it's evolved. And if you'd like to learn more about policy issues related to spectrum management, please take a look at Policy Tracker's training courses, newsletter and research, all of which is available on our website, policytracker.com.